And even though we schedule for 6:30, we let people, we give maybe 5-10 minutes for people to join before we get started.
Perfect. And okay. Damien, you just have us presenting for about 5 to 10 minutes, correct?
Correct, yeah.
Okay.
We can take as long as you need, but you said you need 5 minutes, so we can. It's up to you, really. Okay. So on my other screen, I'm going to monitor how many people are in here. So what I could do is I also need to share your screen. So let's see. Okay, so Matthias, try to share your screen so that I can add you to the stream.
All right.
All right, perfect. So basically, I will introduce you. I will just introduce the evening, and then after that, I will introduce you. Then you get started. Then when you finish, I will take over from there.
Mm-hmm.
Okay. So we're all set. Let's just wait for people to join. So in the next, I reckon by 6:45 ish, we should get started. If you want, you can take a leave. It's up to you. You can hang around, but let's aim to start 6:45.
Okay.
Sounds good.
Let me try to. Did you stop sharing?
I did not. Let me see.
Okay.
Says I'm still sharing.
Maybe I need to add it again. All right, I can just do it. So you're based in Dallas?
I am not. So I'm based in Chicago.
Oh, okay. Wow. Okay. How is the weather over there? Is it good?
It was actually pretty good today. I think it was mid 60s, which is pretty surprising for the middle of December.
I know. All right. So you're getting all ready for Christmas?
Yeah, getting ready. I was telling the kids they might not have any snow this year for Christmas.
Yeah, that's not normal for us here. So we don't really expect it.
Hmm.
Mhm. Okay, we have about 5 people joining, 6 people now. So in 10 minutes time, usually we get like half the number of RSVPs, and we had about maybe 25, so maybe somewhere around 10, 15 people.
Yeah, okay.
Hi, Kelsey. So should I introduce both of you or just Matthias?
I think it could probably just be me.
Okay.
That's certainly
Okay.
up to Kelsey if she wants to jump on in.
I think she's on mute. So we have, 7. It fluctuates between 7 and 8, but in a few minutes we should get started.
All right.
We still waiting for everyone to join, Damien?
Yes, in a minute or two we get started.
Perfect.
Yeah. So I was asking Matthias if I should introduce both of you or just one person.
Just Martez is great. I will actually go off camera and just be a fly on the walls unless Martez needs me to talk about the movie premiere.
Okay.
Is that
He's
okay,
right.
Martez? You good with that?
Yeah, he's right. That's what
Yep.
he said.
It's good for me.
Perfect.
All right. Any moment now I'm going to get started. All right. Hello, everyone, and good evening. Welcome to the last meetup of the year. And today, I'm pleased to have a guest with us here, the sponsor for today's meetup, and he's from Morpheus Data. If you look at your email recently, in the last couple of minutes, you should have seen an email from me inviting you to RSVP for the Matrix movie. So that offer is given by Morpheus Data, and they are here to give us a short presentation. And then after the presentation, I will take over, and then I will give my own presentation. So I'm excited, and I can't wait to hear them tell us what Matthias has to tell us. So let me introduce the speaker from Morpheus Data. His name is Matthias Reed, and I'm going to hand over the microphone to him to tell us what he has to tell us. And then, like I said, I will take over from him when he's done. All right, Matthias, it's now your turn to take over.
Thanks, Damien. Appreciate everyone joining and taking the time out to hear a little bit about Morpheus and what we do. So as Damien mentioned, my name is Matthias Reed, Director of Technical Marketing with Morpheus Data. We're going to walk through a brief introduction in terms of what the Morpheus platform does and provides for our customers. So really the impetus is focusing on, in particular, enabling hybrid cloud application orchestration for VMs and Kubernetes. And so really it's, as I mentioned, a brief introduction to the Morpheus platform, the capabilities that it can offer and it can provide. Really focused on the relevancy as it relates to the platform's capability. When we talk about cloud, whether it be private or public, as well as Kubernetes, then one of the things to mention is that there will be further technical, one would say, deep dives and discussions at later events as it relates to the meetup, that we can delve even deeper into the broad capabilities that the Morpheus platform provides. Additional information, if what we talk about today does pique your interest and you can't wait until later events, feel free to go to morpheusdata.com for additional information. There's an opportunity to request a demonstration from one of our sales engineers as well. And one of the big things that Damien has also mentioned is the invitation from us to attend the Matrix movie event, which is actually going to be next week. So let's get right into it. So one of the challenges that our customers typically face, which is large enterprise organizations, is the sheer complexity as it relates to having to deal with on-prem environments, public cloud, the myriad of tools and platforms, Terraform, additional infrastructure as code, Kubernetes, traditional virtual machines, serverless, all these different constructs create problems in terms of just dealing with the complexity that inherently comes along with just the number one, the sprawl or the breadth of technologies, as well as just the depth of expertise that's often required as part of interacting and managing enterprise environments. So one of the things I typically talk about as it relates to where does the Morpheus platform play? We see the complexity. We all know the complexity in IT environments. As a practitioner myself, one of the challenges was always and still remains is continuing to stay at depth and aware of the latest and greatest as it relates to tools, paradigms, as well as just the technologies themselves. And so the core areas where Morpheus plays from a platform perspective are what I typically term as workload lifecycle management. And so that is the provisioning, day two operations, and final decommissioning of a workload. The workload could be, as an example, a virtual machine running in a VMware vSphere environment, could be an EC2 instance running in AWS, could also be a container running in a Kubernetes cluster, could also be a cloud resource provisioned via infrastructure as code. So really where the Morpheus platform plays at its core functionality is being able to facilitate the automated end-to-end provisioning of workloads, but as well as provide day two visibility from a management perspective for, as an example, EC2 instances provisioned to execute day two operations. That may be the execution of a script, whether it's Ansible, Bash script, PowerShell script, with native integrations to those industry-leading automation tools native to the platform. And then in addition to the provisioning, day two management, then there is the decommissioning aspect. And so one of the other big benefits of the Morpheus platform from a integration perspective is, as an example, spinning up a virtual machine requires an enterprise environment, requires the integration or creation of things like DNS records, CMDB records, also reserving IP addresses, all those various things that are necessary and oftentimes slow down productivity in enterprise environments can be automated in an end-to-end fashion utilizing Morpheus' native integrations with those various technologies, whether it be a Blue Cat or an Infoblox from an IP address management perspective, DNS. And then in addition to that, being able to leverage phase-based automation in the context of being able to execute an Ansible playbook or install a Puppet agent and deploy a set of configurations to a system utilizing that automation. Then in addition to that, one of the things I typically talk about, and I'll talk a little about later, is the ability to compose various different constructs and objects, whether it be combining a virtual machine running in VMware vSphere with a workload running in Kubernetes and start to be able to tie those together in a meaningful fashion is one of the big benefits of the Morpheus platform. And then also being able to layer in self-service. And so having a self-service portal for the request of all those things. And then in addition to that, being able to also execute ad hoc automation as part of the Morpheus platform. So we'll keep moving along. So as I mentioned, really focused on being able to deliver a self-service experience from a platform.
Uh-oh. Martez, I think we've lost you, friend.
Yeah, he's been breaking from my side. I'm not
Individual.
sure if that's the same for everyone.
Martez, we lost you for just a minute there. Can you start at the beginning of the slide again? Sorry.
Yeah, we'll start again. All
Thank
right.
you.
So really the focus is on, as I mentioned, Morpheus platform providing self-service capabilities for environments of enterprise scale. And so really focus on being able to enable developers, non-system administrators, but also administrators to consume IT resources in a self-service fashion. So going into the Morpheus self-service catalog to request a single instance that includes all of the configuration necessary as it relates to tie into internal systems within your environment, as well as being able to utilize the Morpheus platform for standing up entire application stacks, deploying workloads to Kubernetes, being able to go into the same self-service catalog, and being able to request ad hoc automation or orchestration. Really, the possibilities are, one would say, endless in terms of the self-service capabilities that the platform can provide to harness the IT assets within an enterprise organization. And so building and managing is a core aspect of the platform. So as I mentioned, being able to stand up virtual machines on-prem, being able to stand up instances, public cloud, being able to leverage infrastructure as code like AWS CloudFormation, ARM templates, HashiCorp Terraform to stand up cloud resources wherever they may be. Also being able to provision Kubernetes clusters within the Morpheus platform, either using Morpheus's built-in CNCF certified Kubernetes distribution, deployed on-prem as well as the public cloud, but also being able to utilize Morpheus's automation orchestration capabilities as a framework for standing up additional Kubernetes clusters, whether that is an OpenShift cluster, a VMware Tanzu cluster. One of the things I've stood up recently is a K3S cluster in my VMware vSphere environment, and really just makes it extremely simple. Also being able to leverage the Morpheus platform from a day two management perspective for instances, virtual machines, but also from a Kubernetes cluster perspective. So the Morpheus platform can provide day two management capabilities as it relates to Kubernetes clusters that it has provisioned, as well as being able to bring in brownfield or existing Kubernetes clusters to get visibility in terms of the workloads that are running on the cluster, also being able to get insights to the objects within the Kubernetes cluster itself. One of the big things that the Morpheus platform really focuses on is being able to provide a secure experience, especially when you start talking about self-service. One of the things that typically goes hand in hand is ensuring that the self-service components or items are being delivered in a secure fashion to enable them to be consumed in a self-service fashion without the gatekeeper, so to speak. So the Morpheus platform has granular role-based access control in terms of who can get access to what, as far as self-service catalog items, as well as various execution operations within the platform. The platform is multi-tenant or has multi-tenancy built in as a core principle or construct of the platform to ensure that there is a very granular level of segregation between various tenants within the platform. Then also a number of capabilities as far as being able to utilize the platform's functionality for helping to ensure security as well for given workloads that are deployed, utilizing lifecycle policies, compliance policies, as well as various other hooks that the platform has from a security perspective. Number of the things that I've mentioned, just to reiterate, Morpheus platform can deploy virtual machines, on-prem, VMware vSphere, Nutanix, OpenStack, as well as into the public cloud. Also being able to leverage the platform, as I mentioned, for deploying Kubernetes clusters, whether it is utilizing virtual machines or it is a cloud-managed Kubernetes cluster, such as an AKS cluster, GKE, or EKS as well. Also being able to leverage the Morpheus platform as part of as an example, a CI/CD pipeline to automate the stand-up and configuration of a Kubernetes cluster or virtual machines as part of that process. Really provides the extreme value, in my opinion, for organizations that need a platform to centralize the various functionalities in terms of automation, orchestration, as well as we're seeing now more and more, the proliferation of various computing models across organizations, which include virtual machines, containers, and Kubernetes, PaaS services, or cloud native services, as part of the offering that organizations are looking to provide. And then finally, the Morpheus platform has built-in visibility in terms of usage reporting, cost reporting for public cloud spend. One of the things that the Morpheus platform provides is for those that are utilizing Morpheus platform for public cloud is being able to enforce policies to help reduce cloud spend, but as well as get visibility from an ongoing perspective into what the cloud spend is, and be able to leverage the Morpheus platform for getting that additional visibility. So to bring it all to hopefully put a nice bow on it as I get ready to wrap up. Really, what's the value of the Morpheus platform? So really looking to be able to provide a self-service platform, as I mentioned, for the various computing models. As we most of us know, within especially large enterprise environments, there's a mix and a hodgepodge of various designs, solutions, tools, and being able to have a centralized platform to encapsulate all that in a self-service fashion is incredibly powerful. So being able to bring together Ansible playbooks, Kubernetes deployments, Kubernetes clusters, infrastructure as code for public cloud, being able to leverage the Morpheus platform for providing self-service for on-prem resources. So really be able to provide that centralized platform. So really, as I've mentioned, a lot of the capabilities really starts to unlock the really the ethos in a lot of ways of what DevOps has tried to provide. It's trying to bring Dev and Ops closer together. And in my opinion, what we've talked about in the Morpheus platform really helps operations teams unlock that real capability from an automation perspective to adopt many of the practices associated with DevOps. So really where the Morpheus platform fits from a core use case perspective is environments that are oftentimes looking to provision a number of workloads, and not so much the static environments, but also have, as I mentioned, that myriad of on-prem, colos, hybrid, multi-cloud environments. Really drives and talks to that complexity of where the Morpheus platform really fits well, is being able to provide that centralized platform for those heterogeneous and complex environments. Lots of Kubernetes containers and virtual machines. So having, as I mentioned, once again, that centralized platform. In the areas where the Morpheus platform may not be the ideal fit is for organizations that have gone all in on a single cloud, or just don't do a lot of provisioning as it relates to standing up workloads on a daily or monthly basis. And so as I've wrapped up, hopefully there's been a good sense gained of what the Morpheus platform looks to provide as a capability. And so
Did we lose them again, Damien?
Yeah, we lost him again.
Oh, there you are, Matthias. Sorry, we lost you for 2 seconds.
All right, so I think you all lost me right as I got to the end here.
I think you did. Yeah.
Talking about the Matrix. So December 22nd, next Wednesday, Morpheus is sponsoring a screening, so to speak, of the Matrix movie. And so, as Damien mentioned in the lead-in, feel free to register to secure your spot. So as soon as possible, would need to register for the event to have your seat reserved. And so, as once again we mentioned, Damien sent the registration email earlier. So please reserve your spot if you want to come join us and partake in the latest of the Matrix series. Appreciate everyone's time, and thank you for having us, Damien.
All right, thank you, Matthias. So thanks for the introduction into your platform. So now we we understand more about the Morpheus data platform. And, like Matthias said at the beginning, we're going to bring them in here a couple of times to show us more into what the platform entails. So for now, I'm going to give a few minutes for anyone, if you have any question to ask. To ask question, you can just send it as a text. So if you look at your YouTube, there's a chat where you have to, write your question. And while we're waiting for your questions, I will just ask Matthias one question. And that is, how do we get started if you want to use a platform?
Yeah, so one of the best ways to get started is by going to morpheusdata.com. We do have a community edition, which enables you to download the Morpheus platform. It is installable on a Linux distribution. So you can install it on a Linux virtual machine, whether it's on-prem, your local lab environment, public cloud, kick the tires. And so the license does provide the capability for up to 3 clouds, as well as 25 workloads. And we term workloads as typically virtual machines or instances, but there's a gamut of what it also covers. But typically the 25 workload elements are more than enough for everyone to get started. Also has the capability of being able to leverage it for automation orchestration capabilities as well.
Okay, that's excellent. So if you have any question, we're still waiting. You have like a minute more. In the meantime, I'm going to let Matthias or Kelsey tell us a little bit more about the Matrix movie. If you have seen the earlier versions. Because I'm really excited to watch this new version coming out.
Yeah, I mean, I'm pretty excited as well about the opportunity. Certainly given the gap between the last one and our most recent one, especially given what all that Keanu Reeves has done from an acting perspective, it'll certainly be interesting to see how the movie changes or will change in terms of a dynamic, given his maturity as an actor. Also, the I guess, depending upon your view of how Lawrence Fishburne's acting was, him no longer being in the movie, it'd be certainly an interesting thing to see how that plays out.
Definitely. All right. Thank you for the opportunity. Kelsey, do you have anything to say?
No, Damien, thank you for letting us join. Thank you for sending out that email. If anyone does want to join us next week, it's at the Cut Cinema in Frisco, so just north of Dallas proper. And we'd love to see you. There's about 20 seats left. So if you would like to come and bring your +1, please RSVP now so we can save you a spot.
All right. Excellent. Thanks guys, for coming. And I'm going to now start my own presentation. Feel free to stand by or feel free to leave, whichever way you prefer.
All right.
Thank you. Thanks, guys.
Have a good night. Thank you.
Thanks. You too. Bye. All right, guys. Now it's my turn. I'm going to give my own presentation. So let me share my screen and then we will get started. Okay, so let me bring up the slide. So for today, what I'm hoping to do is not going to be it's not going to be a heavy presentation. I'm just going to share with you a very interesting project, an open source project. And this is very interesting because Redhat did a survey recently, and what I'm going to present on is one of the most popular utility that people are using in production. So if either you're using Kubernetes at the moment or you're about to start using Kubernetes, I think you will find this very, very useful. And also, we've been talking about security in the past couple of months, and today is still kind of on security, but it's not going to be that heavy. All right, so I want to make my presentation to be friendly to beginners. So if you have never worked with Kubernetes before, you still gain something out of it. And if you have been using Kubernetes for some time, you will still gain something out of it, hopefully. So that is what I aim. It's not going to be a very long presentation. It's just going to be showing you a few things which you need to understand, and then we might round up. So my name is Damien Igbe. For those of you who don't know me, I'm one of the organizers for the meetup. And as a sponsor for the meetup, we have a company behind it. And the name of the company is here called Cloud Technology Experts, which I'm showing on the screen. So basically, we do training on cloud native and cloud native technologies, things like Kubernetes and microservices and DevOps and AWS. So if the things we're going to be talking about today interest you and you want to go deeper, like becoming a CKA certified Kubernetes administrator or certified Kubernetes developer or any of those kind of technological courses, if you need help with that, we are here to help, basically. All right, so let me start the presentation. We're going to start like from the very basic, so that, like I said, to bring people on board, to have them understand Kubernetes. All right, so here, what you are seeing on my screen here, I'm going to show you a Kubernetes cluster deployed. Okay, the Kubernetes cluster is deployed, and I'll show you a few things on it. But before I show you that and go on with the presentation, let's understand what is Kubernetes and let's understand the architecture of Kubernetes. Okay, before that, let's see what the agenda looks like. So this is what the agenda looks like. We're going to look at the Kubernetes architecture. Then we explore Yammer Files. That is how Kubernetes creates its own resources. Then after that, once we understand how Yammer Files work, then we'll talk about KubeLinter, which is the main topic of presentation for today. And in between, I'll be giving you some demos. And then after that, we'll basically conclude. All right, again, like I said, if you have been using Kubernetes for some time or if you're new to it, see it more like a refresher. So if you haven't used Kubernetes before, Kubernetes architecture is divided mainly into two planes. We have what we call the control plane, then we have what we call the data plane. The control plane is basically where the control comes from. That is why it's called a control. That is what the user interacts with. Anytime you're trying to use Kubernetes, it is the Kubernetes control plane that you talk to. You don't really have to talk to the data plane, but this is where your workload is going to run. So anything you are trying to do, your workload will be sent to the nodes. So let's say, for example, you have a microservice application you're trying to run. The microservice application will be sent to the nodes. But when you are trying to deploy the microservice application, you do that through the control plane. So on the control plane, you can have like maybe a node or three, like one computer or three computers. It's usually an odd number of master nodes here. And then on the data node, you can have as many nodes as you want. You can have it up to 1,000. In fact, currently, I think the benchmark a Kubernetes cluster of up to 5,000 nodes. So really, you don't have any limit, okay? There's no limit to this, but this one usually is going to be like odd numbers. And for most production environments, you have them like 3 nodes, all right? So within the control plane, you have the Kubernetes API server, you have the scheduler, then you have the controller, you have the kube controller manager. So pretty much, yeah, just to summarize, as a user, you are going to be interacting with the Kube API server. Anything you do, will be talking directly with the Kube API server. And then the scheduler is the one that will deploy your workload, send your workload to the worker nodes. That's all it does. Scheduler look at your workload and says, okay, I think I need to put them here or here or here. That's what it does. etcd, this data is a database service called etcd. This is where all your information gets stored. So you can persist them if you want to refer back to them later on. All the information is stored right here. And then you have the kube controller manager. The kube controller manager is the one that has to take care of certain objects that are called controller objects. For example, a deployment object is called a controller object. Basically, what a controller object does is like a control loop. And you can see the diagram here. It's like a control loop. It's always looking at your object to make sure that your object meets the desire. So there's a concept of the desired state, like we have it here, and then the current state. So the control manager is always ensuring that what you present to the system is always what you get. In other words, if I need to have 4 replicas of my application running, when I do scaling, then the control loop will ensure that I always have 4 replicas running. If any of the replicas dies due to one reason or the other, the control manager can try to bring it back. Okay, so there are a couple of control objects, but the one that we're going to deal with mostly, or the one you'll be using mostly, is called the deployment object. All right, so that is kind of like the short introduction to the architecture. If you want to deploy this, like I said, you can just maybe create some virtual machines on your VirtualBox or any hypervisor you have, then deploy the control plane on this one virtual machine, and then deploy the worker nodes on the rest of the virtual machines. Okay, so if you have that in your laptop, you can start working with it. So that is the architecture. But let's look at it in real life. So here I have a cluster. If you want to interact with Kubernetes, you have to use this tool here called kubectl. kubectl is pretty much like Kubernetes control, CLI. So it's what you use to do almost everything. You can also manage Kubernetes from the dashboard. But apart from managing it from the dashboard, this is what you're going to use. And again, like I said earlier, anytime you run this, it talks to the API server on the control node. All right, so if I say kubectl get nodes, it's going to show me how many nodes I have on this cluster. So pretty much it's telling me that I have 1 master node and I have 1 worker nodes. Okay, so just 2 nodes. I actually have another cluster here, but it's also just kubectl get nodes. It's also 2 cluster nodes. And so I can do stuff here, I can do stuff here, but these are separate clusters that I've created here to show you. So again, if you say kubectl get pods minus n kube system, so you are trying to see your pods in the kube system namespace, you see kube system. Kubectl get pods minus n kube system. Okay, so now it's showing us all the components I showed you earlier. For example, it's showing us the API server, it's showing us the controller manager, it's showing us the scheduler, okay, and then it's showing us some other components which are coming from the worker nodes. All right, so you can see all the pods. So Kubernetes itself is running itself. It's like Kubernetes is kind of deployed in Kubernetes because these are pods. These are all Kubernetes pods running Kubernetes itself. All right, so that is the architecture as far as it goes. So now that we have the architecture, I will walk you through how to create an application. And this application can be like any microservice application that you're trying to create. Okay, so just to show you that we use Yammer Files. Okay, Yammer Files a lot. I don't know if you're familiar with YAML. YAML means yet another markup language. Okay, so it's a data serialization format which you can use for your applications. The good thing with things like YAML or JSON or XML is that they are independent on the platform. So for example, if you're writing your application in Java, Java can understand JSON or YAML, or if you're writing it in Python, whichever language you're using, they should all be able to read the information that you present in this data serialization format. So in Kubernetes, we use mostly YAML, though you can use JSON as well. You can use JSON. In fact, Kubernetes natively uses JSON. So if you use YAML, there have to be a kind of a conversion from YAML to JSON, all right? Which means if you use JSON, maybe it could be some microseconds faster. But YAML is a lot more intuitive. It's a lot easier to read for people than JSON. So almost everyone writes their manifest files in YAML. But the whole idea here is that if I want to create any resource, if I want to create a microservice, for example, I need to first of all create my YAML file. And in my YAML file, I need to describe how I want my object to look like. Then I need to present that to the Kubernetes API, and then the Kubernetes API will help me create the object. And then I can have my application running. And that is what I'm going to show you in a kind of a short walkthrough. And what I'm showing you is going to be very true. It doesn't matter how complex your application is, the process is still going to be the same. Okay, so first of all, I will show you a demo of that. Then I'll show you how to understand Yammer files. Then from there, we come to KubeLinter and then round up. Okay, so here's my Kubernetes cluster. If I want to see all the objects, Kubernetes, we call them Kubernetes objects or Kubernetes resources. If I want to see all of them, I can say Kubernetes API resources. And that will show me all the objects that Kubernetes understands. And you see there are quite a lot. Don't get confused. This is the name. This is the short name I can use. This is the version for the API. This one is asking us, where it's telling us whether this object is restricted to a namespace or the entire Kubernetes cluster. So basically, there are a couple of headings, columns here, so a couple of rows, columns. So we're just going to look at this first one here. So if you look through, you see that you have a couple of objects here. The one I'm going to show you are just going to be the pod, kubectl get pods, like the one I showed earlier. So first of all, what is a pod? A pod is considered to be the smallest unit of deployment in Kubernetes. If you like, call it a container. There's really no difference. Well, slight difference. But for a beginner, just take a pod to be a container. In reality, a pod can contain more than one container, but a container can only contain one container, if you get what I mean. So that is the only difference. A pod can contain more than one container, but a container can only contain one container, all right, if that makes sense. So basically, Kubernetes creates an abstraction around the concept of a container and call it a pod. So the way it runs is that it works is that before you create a pod, you need to create a YAML file, and then the YAML file can now go ahead and create the pod. So another object which is very important is, I just talked about pod, is called the service, kubectl get SVC, service object. The service object is like the load balancer. When you scale your application and you have a couple of replicas, the next question to think about is how do you actually access those replicas as one? To do that, you need to have a front-end load balancer that points to all the replicas. And then if the customer wants to access the application, they can come through the front-end load balancer. So that front-end load balancer, in essence, is what Kubernetes called the service object. So you're going to see me demo that as well. Another object which is very important is called the deployment. Kubectl get deployment. This one, I don't have any deployment at the moment, okay? But the three most important objects to get started in Kubernetes is the pod, the deployment object, and then the service object. With those, you can do an awful lot of things with Kubernetes. So let me just walk you through this simple example. Basically, what I'm going to do is that I want to create a pod. That pod will just be running Nginx. But that Nginx could be your actual microservice, but I'm going to use Nginx. Okay, so there are two ways you can create your objects. You can either create them from the command line. That is what I'm going to do. Or you can open up your file and then open the YAML syntax inside of it. I'll come back to that in a moment to make sure you understand what I'm saying. But now to create a pod, I can say kubectl run Nginx. That's the name I'm giving it. I'm giving it the name Nginx. Now every pod needs an image to run. And I'll say image, I'm giving it is Nginx as well. So here I say kubectl run. Then I give it the name of the pod. Then I give it the image name Nginx. So if I do press enter, it said pod Nginx created. So I want to see if my pod is running. I do kubectl get pods. And now it's running. So very fast. It's already running now. Now, how do I see this pod? Well, this is Nginx, right? So if I curl the IP, I should be able to see the welcome message. So I can say kubectl get pods minus O wide. O wide will give me the IP address of this pod. Okay, remember a pod is a container. A container is pretty much like a virtual machine. They are just doing exactly the same thing. They are a unit of deployment. So if I do curl and I give it its IP, this is already running on port 80. So now I see the welcome to Nginx. So I see welcome to Nginx and then a whole couple of other information here. So my container is running. If I had another microservice in here, that microservice is now going to be, accessible, to be available for me to see. Okay. So now that I have my microservice running, the next question is, how do I actually view it from outside? Now I can view it locally, like you see I did here, but how do I view it from outside? For example, if I want you guys now watching this presentation to be able to access this my application, how do I do it? Or if I want to access it within my environment here, also, how do I go about doing that? And this is where the service object comes in. Remember, I said the service object is like a load balancer. So I need to create a service object to expose it. Okay. Now, there are three types of service objects. I can either have what we call the cluster IP, or I can have what we call the node port, or I can have a load balancer. A load balancer, which actually reflect what this service does, the load balancer. Okay, so if I expose this as a load balancer, I can give you the IP address of that load balancer and you can access it from your home. However, that is not possible except I actually run my cluster in a public cloud, or I have some publicly available IP addresses in my enterprise. That is not the case with me at the moment. I'm not running this cluster in AWS or Azure or anything. I'm running it locally. So I cannot make it possible for you to access this application because it's not running in the cloud. However, I can show you how to make that work within my own environment, which means I will be given an IP within my own environment, then I can access it. So typically, if you want someone to access your application, you want to use type load balancer. If you want to access it locally, you have the option to use either the cluster IP or the node port. All right, those are the two options you have. Now, again, because I'm running this in-house, if I try to create a service of type load balancer, it will go into pending state, except I deploy a load balancer backend. So currently, I have a load balancer backend deployed, and that load balancer backend is called a MetaLB. So because I have MetaLB deployed, I can allocate a service of type load balancer to my application, then I can access it within my own environment. So let me show you that option. So the command to create a service from the command line is to say kubectl expose pod. I'm going to expose the pod, which I created here. Kubectl expose Nginx. Okay, I'm going to expose that, and then I'm going to say port equals 80. Then I can say target port equals 80. Okay, so I'm going to expose the pod, which is called Nginx. I'm going to put it on that. I'm going to make it run on port 80. And anytime I call the service, it will point to Nginx, and Nginx is also running on port 80. So target port is actually the port that is running inside the container. Why this is the port that the service is running on. All right, so let's run that and see. Okay, say resource type Nginx. Okay, so we need to say kubectl expose pod. I forgot to put the pod Nginx. And also I need to specify the type of load balancer. I can say type equals load balancer. If I don't specify any load balancer, it's going to give me a type called it's going to give me a type called cluster IP because that is the default. All right, it said it's invalid. Supported values are this. Okay, so I just change this to capital L. All right, so finally it's now working. It said service Nginx exposed. So how do I see it? Okay, say kubectl get SVC, which is the short form for service. And it tells me my load balancer is here, is running. So my cluster has given me this IP from my network. So if I copy this IP and I paste it on my web browser, I should see the welcome message. Okay, there you go. Now I have welcome to Nginx because I have exposed it as a load balancer. If I don't expose it as a load balancer, I won't be able to see this from my browser. And at the same time, like I was saying, if this were running in the cloud, if I send you this, then you should be able to access this microservice. And even though I'm using a plain Nginx, it could be your actual microservice that you're running. All right, so pretty much I have now been able to create a pod, and I have been able to expose it on an IP, and now we can see it. All right, so that is how you normally want to create your applications. First of all, create them either through pod or deployment object. Normally, you don't want to use deployment. You don't want to use pod directly. You want to create pods with deployment objects, because deployment objects, like I mentioned earlier, is a controller object. So a deployment object will help you to monitor your pod. As it is at the moment, I created what we call the orphan pod. This pod is not being monitored by anything. And also scaling it is going to be difficult. So ideally, I should be able to create a deployment, and then I can use the deployment to control the pod. But that is not how I did it. I did it with pod and service. But I can also do it with deployment and service. But that is not the main objective for today. So I'm going to go now to the objective for today. So now we've seen how we created these files. Now, we did not see the YAML file that created this file. So now let's look at the YAML files. We can say kubectl edit pod. I can say edit pod Nginx. Now the system has given me a YAML file, because when I run the command kubectl run, it generated this file for me automatically. But in generating this file, it has put up a lot of other information which I don't need. A lot of them are just information for the system itself. So let's try to create a neater one. So to create a neat something which is easier for us to understand, I'm going to say kubectl run, the command I ran earlier, kubectl run Nginx -- image equals Nginx. Okay, so I already have a pod running, so let me give it a different name. Let me call it Nginx 1. Okay, I cannot have two pods with the same name. I have the option to go ahead and delete the previous one, or I can give this a new name. So kubectl run Nginx, give it the image. I can say -- dry run equals client. I can say -o YAML. Then I can pipe it to a file. Let me call it pod.yaml. Let me call it Nginx1.yaml. So what I've done now is that I try to generate the YAML file for this pod and put it inside this file called Nginx.yaml. So let's open that file. If I open that file, this is what I'm given as the YAML file for this pod, which means I can create my YAML file. I can create my pod from this YAML file. So let's see how to do that. I can say kubectl create -f. That is, I need to tell it the file name. And now I run it. Again, it says pod Nginx1 created. So if I say kubectl get pods, I see that the pod Nginx1 is also running. That has just been up for 7 seconds. So you learn that you can create objects in two different ways, either just from the command line or by generating the YAML files. And then after that, you can create the object from the YAML file. Or you can even go ahead and go to the Kubernetes documentation and copy a sample YAML file for pod and create it. But this is the easiest way to do it. Otherwise, messing with YAML files are really, really picky. So messing with them can be quite tricky. All right, so hopefully that's helpful so far. Now we see that we can create a pod just by generating the YAML files, so that after we don't have to mess with YAML files. But now that we know how to create the object from the YAML file, let's look at this file again and see if we can understand it. To understand this file, you need to be familiar with YAML syntax. And if you're working with Kubernetes, since you're going to be spending a whole lot of your time on YAML files, you might as well learn YAML. Because even if you copy a file from somewhere, for some reason, that file may not work correctly. And if it doesn't work correctly, you have to try to edit it to make it work. And if you don't understand the syntax of the YAML file, you're going to have a hell of time struggling with that. So let me help you to understand how YAML files are structured. Then from there, we'll go into KubeLinter. So basically, every Kubernetes object has certain things you have to see inside the file. Most of them, or all of them, start with the API version. And API version for Kubernetes is version 1. How do you know that version number? Well, you can actually pick it up from the command I ran earlier when I said kubectl API resources. All right, so if you do that, let's go grab pod. Let's go grab pod. If we grab a pod, we can see that the version for that is v1. So we know that Kubernetes pod is v1. So that is what we put there. Now that is very important. If you put something else, it's not going to work. So the kind is a pod. So which means we're dealing with a pod. If we're dealing with something else, if we're dealing with service object or deployment object or whatever, any of these objects that are listed here, we need to put that in the kind. We need to tell it in the kind, whatever it is. Then there's the metadata section, which is pretty much some information about your object. In this case here, because we auto-generated it, it's telling us the time that this was created. Then it's also telling us some labels. Labels are pretty important in Kubernetes. You use them for a whole lot of stuff, but labels are just some metadata information that you give to your objects. In this one here, the label is run nginx. These are key value pairs, okay? Then the name of this pod is nginx, all right? Not surprising because that was the name we gave to it. And also when this pod was created, if you remember, it said pod nginx1 created. So that's the name. Then you have the spec. The spec here, we have under the spec for pod, we have the containers. This is where we're going to specify the image for our container. Remember, a pod can contain one or more containers. So in this case, we're going to specify, we specify just one container. And so the image we use is nginx. Okay, the name that we gave to this container is also nginx. So the name of the pod is nginx and the name of the container is nginx. Resources, we haven't put anything in there, but we'll come to that in a moment. This one here, both of these, we don't actually need them for now. They're auto-generated, so I can delete them. Okay, even status, I can delete them. Even the resources, I can delete it, but I'm going to need it, so I'll leave it there. This one here was also auto-generated. I can delete it. So what I really need for this to work is not a lot of stuff, okay? And this is the syntax of a pod, and it doesn't change. Under the spec, you can have a whole lot of information here coming down, okay? So this can get very complex, but this is the starting point. This is like the base to get everything working. So let me save it. And if I want to delete it and create it again, I can say kubectl delete -f nginx1.yaml, and my object will get deleted. So if I want to create it again, I can repeat what I did earlier. All right. So now that we understand the syntax of the YAML file, let's go in there and see how YAML organizes this syntax. So go to nginx1.yaml. Now there are three main things in YAML that you need to understand. Any type of this entry can be called a scalar object, which is more like a key value pair, and you have API version :v1. That's a key value. This is just a scalar information. You are just passing a static information onto YAML. All right, so pretty much just as straightforward. You see all of them are following that syntax. All right. Another thing we need to understand is that we have what we call an array, okay? An array or a list. Call it an array, call it a list, is the same. Then the third thing to understand is like we can create an object or a dictionary. Those are the three things you're always going to see. And I'll point out each one of them in a moment. And if you understand what I'm trying to explain now, working with YAML will make a lot easier for you. And of course, your stress level will be much less as well. Notice one thing too, or at least note one thing. YAML files are very, very picky. So for example, if you don't give the right space, that could cause a lot of trouble. For example, here, if I move this just a step back, before it was aligned. Now, if I move it a step back, now I save it again, and I try to create this object, kubectl create -f nginx. Now it's giving me error. Say error passing nginx 1.yaml, error converting that to line 10. It's basically saying that there's a mistake in my YAML file just because I moved that back one space. So if I put it back now and I go back again, now it should work. Now it's worked. So that's to show you that these files can be very, very picky. And if you're working with them, you need to make sure that you understand the syntax. Otherwise, you can spend hours just trying to troubleshoot something very, very simple. So we have those key value pairs. Then we have list. Let's talk about list first. So here we have containers. Then anytime you see this hyphen here, hyphen is indicating that we're having a list. So this list here, like remember, a list is like an array. You can have like an array of fruits, an array of pets, and stuff like that. So here we're having an array of containers. Okay, container 1, container 2, on and on. So all this information here is about container 1. If I want another container, I'm just going to copy this, the whole of that, and paste it down here. And then I can have, let me push it down. So now I can have another container, though this is more for illustration purpose. So technically, this can give me another container, but I don't want to have two containers with the same image in the same pod. So this is just for illustration purpose. If I wanted this one to work, I need to change the image to something else and probably change the name also to something else, okay? So you see that this is a list of containers. First, it starts with a hyphen, then we have all these attributes. Second one did the same thing, and so we have two containers indicated that the hyphen is the beginning of each of the lists of objects that we have in here. So that is a list that you're always going to come across that, okay, as you create your YAML files. Then another one is the object. Here you can consider the whole of this to be an object. So because we're basically just describing the container object, container 1 object, and then here we're also describing container 2 object. So in other words, what I'm trying to say is that we have two lists of objects, first and second. But if you look at here, these are all attributes of the first object. So we're all describing the first object. All these three are describing the same object. All these three are describing the same object, which is container 2 in this case. So that we can. So here we have two things. We have the list. Then we have the dictionary. Okay, the dictionary is the attribute, basically the attributes that are describing this container here. Okay. So like I said, I will not save this one, but I have another one here called a multi-container pod that we can take a look at. So multipod.yaml. So you see we have the same here. Everything here up is the same. Then we have the container here. We name it container 1, then container 2. Image here is nginx. Image here is Alpine. Then here we're passing some commands onto the Alpine. We're passing some arguments into the Alpine. And all these arguments are illustrated as a list. So you can see that is why we have a hyphen in each one of them. But the whole of this and the whole of this is an object. object 1, object 2. So image is an attribute of the first object. Name container X is an attribute of the first object as well. So I hope what I'm saying is making sense. Basically, you are going to see either a scalar object in every YAML file, or you're going to see a list. This is a clear list. Anytime you see the hyphen in front of each one of them, and then you're going to see the dictionary, which is like the object, and that is represent the whole of this, or the whole of this, because the whole of this is describing container 2, and then the first one, the whole of that is describing container 1. Okay, so now when it comes to, remember earlier, when I made a little shift of the object, it was no longer working. Let's see if we can do the same thing here. Here, if I want, I can move this one to the beginning of the line. So the point I'm trying to make here is that for the list object, it doesn't matter where they start from, so long as all of them align. So this will still work. I move it back to the beginning, and then I align all of them. This will work. But of course, I cannot shift it beyond. I cannot put it here, because if I put it here, it means that this attribute is not under command anymore. So this is more of this is strictly hierarchical. The way to look at this is like saying you have a father that has a son, and the son has a daughter. So when you try to represent this family, you need to make sure you put the son under the father. There have to be a shift to the left, to the right. And then when you're putting the children of the son, you have to push them to the right again. So there's going to be the top level, the next level, then the third level, which means the third level is a grandchild of the first one, which that represents the dad. So that is the way to maintain this level of hierarchy. And of course, if you move the third back, it's like I'm moving the child to be under the control of the grandparent. But that won't be correct, because that child is not a direct child of the father. It's like a grandchild. Okay, so if you understand what I'm saying, it's just a hierarchy being maintained. But in the case of lists, I just want to show you that it doesn't matter how you place them, it still works. Okay, so long as all of them are inside or under the object. So this one will still work. That's a kubectl create -f multipod .yaml. This one still work. Excellent. So if I open it and I move them back, see, this one will no longer work because they are not, all the lists here don't align. So it's telling YAML doesn't understand why I'm putting them like that. So if I say kubectl delete -f, I'm going to delete this object first of all. Okay, I'm going to delete that. So let's say kubectl get pods. Okay, I have that in there. Well, because I was trying to delete it, because the syntax was wrong, it's already complaining here. So it's already complaining that it doesn't understand what I put there. So I need to go and make sure they all align, or shift all of them forward to make sure they align. And then this will work. So now I can say kubectl delete pod, and now that should work. Okay, then I'll show you another way to arrange those, and then pretty much I'll go to KubeLinter, which is the main topic for today. But at least, hopefully this helps you to understand that we work with YAML files when you're dealing with Kubernetes, and you need to understand the syntax for YAML files, because that will save you a lot of time. And then after that, having understood how important these files are, we'll see what KubeLinter can help us do. So let's wait for this to finish, and then we will proceed from there. Okay, so let's clear the screen and have a clean environment. So I want to show you just one more example on how you can change the list. So let's say vim, I have this file here, pod list. So remember earlier, all these attributes, all these parameters were put under the command, okay? But now I put all of them on the same line, and then I separated them by a comma, and I put the open and close bracket between them. That is also valid. You know, this is the one we had earlier. See, this one, the lists are all listed here, but in the second one, all of them are on the same line. So again, when you look at that in YAML files, don't get confused. They're just the same way. YAML has a way of representing this information, presenting them in two different ways. And that, so my overall observation is that it's a lot more flexible to deal with lists. But when it comes to the objects, you just have to make sure that you maintain the hierarchy. Another thing, though, is that because this can be highly, highly picky, you can always use something to check your syntax. Okay, so if I copy the whole of this here, I can go to a website called YAML Lint. I think I probably have it here. Yeah, go here, come here to YAML Lint and paste your YAML file here, and it will tell you if it's good or not. So it says valid YAML. And then it helped me to kind of reformat it to make it easier in its own way of looking at things. But that's a valid syntax. If it's not, it will complain. For example, if I move this one back like I was doing earlier, and I say go, okay, it corrected it. Either it corrected it for me or it tried to explain it in a different way, which may not work. All right. So let's see if what it's suggesting is correct. If we copy that here and just the vim test.yaml and I paste it there, and then let's try to create it. kubectl create -f test. All right, so you see it corrected it for me. So otherwise it wouldn't have worked, but it corrected it for me and now it's working. So it's always good to also try to have a way for validating your YAML files so that you don't spend a lot of time creating them. Also, it also makes sense for you to use an editor. I'm always using Vim there, VI, but if you use something like this, which is Sublime Text, you see that, I don't know if you can see that, it's quite faint, but you can see there's that line there that is showing the hierarchy. It's showing that all these objects, API version, kind, metadata, spec, all of them have to be on the same line. Then for the second hierarchy here, when we talk about the volume here, it's showing that this one's here too have to be aligned. All of them have to be on the same line here. Then there's a third line here too. The third line here is showing too. So if you're working with YAML files, it also helps to use an editor that can really help you see things more visually. All right. You can still, to some extent, see with VI, but you know, some people may prefer to use a real editor that can help you highlight the syntax. All right. So those are some of the things I wanted to show you here. Now we can talk about KubeLinter. All right. So like I said earlier, we are working a lot with YAML files. Now, the fact that I'm able to create that pod doesn't mean that this pod is actually secure from security perspective, because like everything in life, there are best practices and there are bad practices. So that file I just created, kubectl, kubectl, get pods. I have my pods running, got a couple of pods running, but how do I know that these pods are actually safe? Have I taken care of all the security best practices to ensure that these files are actually running as securely as possible? Or are there a lot of holes in them? That is where KubeLinter comes in. KubeLinter is a CLI tool, open source project that helps you to see whether your YAML file has best practices configured within it. Okay, so on its own, it's quite a simple tool to deploy it. To use it, I need to come to my laptop, okay, because this is something that developers will use on their laptops. Okay, you don't have to. This is my cluster. I log onto my cluster and I'm using them directly from there. But what I'm trying to show you here is a tool on my laptop, so you can install it. You can install it on your laptop, and it's let me show you the project. KubeLinter is right here. You can look at it. KubeLinter. Go to that docs.kubelinter.io. Then it shows you how to install it. You go through it depending on which environment you're using. First of all, you install it. And then anytime you create a YAML files, you just use it to check. It will tell you whether your files are properly configured according to best practices or not. And this tool, like I mentioned earlier, if you look at this survey here done by Redhat around August this year, this tool is the most popular tool that people are using. You can see right there, KubeLinter, 32%. Well, OPA is also popular, both of them 32%, but it's one of the top tools that people are using. And once I show you some examples, I think you can understand why, because when you put your YAML files in production, when you use them to create objects, you can't know whether they are secured or not. And if your environment is not secured, if your YAML files are not secured, pretty much you can easily get hacked. And since to a large extent you are doing everything with YAML files, it makes sense that you have something that will help you validate your YAML files to ensure that they have conformed to security best practices. So it's not more than that. It's just a tool to help you check how secure your YAML file is. Is it running as root, which is not good? Is it setting some resource quota on your pods? Resource quotas and pods are very important because in a Kubernetes environment, you can have a lot of applications running. And if you don't tell the pod how much resources it can use, it will use the whole resources on your server. But you don't want that to happen. You want to be able to have a kind of a quota or a restriction as to how much resources a particular pod, for example, can use. And so if you don't specify this resource limit, KubeLinter will tell you. It will say, this is not good. You may have to make sure you specify the resource limit. And then if running a pod as root is very bad as well, because pods run as processes. So if someone happened to get into your pod, they can try to escape from the pod to the main server, to the main blade where your application is running. And if they do that, they can cause a lot of havoc because it's running as root. In Linux, root is the administrator. They have all the power. So someone can easily break out and do some havoc to your environment. And so in that case, you don't want any pod to be running as root, except you really, really want it. If you think that is a use case for your pod, then it's understandable. But that is something that is highly, not recommended. Don't run your pod as root, except maybe you know why you want to run it as root. So things like that, KubeLinter can help you check them. Also, there's something we call secrets and config maps. Secrets and config maps are configuration variables, okay? If you store those inside your YAML files and then store those YAML files in GitHub or something like that, anybody can grab them and use them to hack into your environment. So you are required, or at least as best practice, to put them in secrets and config maps. And so KubeLinter can also tell you if you are not following the best practices with regards to how to store your credentials. So it has a lot of best practices configured within it, and I'll show you some of those best practices, at least based on how it's configured. Then there are a lot of checks you can run to check your pods, your YAML files. Okay, but a few of them are on by default. So even though they have like close to, I don't know, maybe 80 checks or something like that, they enable about 20 by default. Okay, so if you want to run against everything, you can tell the system to do that. If you want to run just a few of them, you can also tell the system to do that. All right, so in essence, that's what KubeLinter is. Check your YAML files, tell you if they conform to security best practices. Otherwise, make the suggestion for you to go ahead and fix them. All right, so let's go through that. Let me show you a few examples. So already I'm in my laptop. KubeLinter is installed. So it's already installed there. If I say KubeLinter, it's coming up here. First of all, checks. We're going to use lint. Lint is going to help us. Lint is the one that will help us check to see if our files are good or not. Then let's see the checks that are inbuilt. I can say KubeLinter checks. list. So it's showing me all the built-in checks in the system. If you want to know the best practices, this is it. Okay. If I pipe that, I can see if I can pipe that to KubeLint.yaml. Then if I open it, KubeLint.yaml, so I see all the checks that are inbuilt. Number one, access to create pods. Description indicate when a subject has create access to pods, blah, blah, blah. Enable by default, false. Enable by default, false. So a lot of them are here, not enabled by default. This one is enabled by default. Then if you go down, this is enabled by default. This enabled by default. Enabled by default means when you run a check, this will be your pod or your YAML file will be validated against this. Okay, any of the default. Then later on, I'll show you how to restrict or just tell the system only the ones you want it to check. Maybe you don't want all the default ones. You just want it to check against one or two. You can do that as well. You can do a lot of customization as to how you want the system to check. But you can see that we have a lot of them here, and a lot of them enabled by default, but a lot of them, again, not enabled by default. So these are the checks. These are the best practices, so to speak, that are inbuilt into this system to help you check. All right. So let's do what we've been doing before. Here I have a folder. Let me cut this Nginx file. Okay, so let's do it this way. I'm going to come here. Remember that I had a YAML file that I created earlier. Okay, that YAML file, let's validate it. Let's see if it's actually good. Cat pod.yaml. Remember, this was the one that I auto-generated. I auto-generated this one, and it's quite simple. Okay, so let's copy that. Okay, let's actually do this one, Nginx 1. This was the one I just showed you last. So I'm going to copy that, bring it to my laptop, from my cluster to my laptop. Then I'm going to do vim nginx 1.yaml. I'm going to paste it. All right, so I'm going to save. Then I'm going to check if this YAML file is actually good, if it conforms to all the best practices. I just say KubeLinter lint nginx 1. KubeLinter lint, see the syntax, nginx 1. I run that. KubeLinter, I need to put lint. Need to be KubeLinter lint. All right. See that YAML file we generated that was working as very nicely. KubeLinter found 6 errors. It's saying that there are certain things I need to do to make sure this is conformed to security best practice. But the good thing is that it's going to tell you what the problems are. Then you can go ahead and solve them. It said KubeLinter container Nginx 1 does not have read-only root file system. Okay, it doesn't have a read-only root file system, which means it has a read-write root file system, which means someone can go in there and write onto the pod. But these days we talk about immutable containers. Containers you shouldn't be able to change anything on them. So it's saying that this is not a best practice. Again, notice this. Even though the system may tell you this is not good, it's up to you. If you think it's good, you can ignore it. All right. If you think in your own organization, this is not bad, or however I look at it, if you think you can do away with that, by all means, ignore it. But if you want to be really, really secure, then you should take a look. Now look at this one I talk about. Nginx is not set to run as root, to run as non-root. So it's running as root. The reason is because we did not specify. Okay, so let's look at the solution. The solution for this one here is set read-only root file system to true in the container security context. So a container has something called security context. It's saying you should go ahead and set it to read-only root file system to true, which means you shouldn't be able to run it in read-write. So this one here, it also has a solution for you. It said set run as user to a non-zero number and run as root to true. So it's basically saying do not run this pod as true, as root. If you want more information, he also gave you where to check that off from Kubernetes documentation. Then what I also talk about in terms of setting some limit, some quota for your pods, is also talking about them here. It failed. There's something called the request, and there's something called the limit. So what is a request and what is a limit? This has to do with how pods are scheduled. All right. I told you in the architecture, the scheduler have to schedule your pods. All right. When the scheduler is trying to schedule your pod, it has to know whether the node that is trying to run the pod on has enough resources. And so how does it know if the pod has enough resources, if the node has enough resources to run your workload? The only way it can know is if you tell it how much resources your pod actually need. If you don't tell it how much it needs, how will it know? So in that case, it is not a good practice because in one way, it will say, okay, since I don't know how much resources your pod needs, I'm going to run it anyway. Then if it does, maybe your pod doesn't require more resources than what the node has. So maybe your pod gets scheduled to node 1. Node 1 has only 1 CPU. But in reality, your pod needs at least 2 CPU to run. But because it did not take Kubernetes, it just scheduled it there because it didn't tell it. And now your pod is not going to work well. That's on one side. The other side is that in Kubernetes, a pod can use as much resources as it wants if you don't tell it how much to use, which means that pod is going to be, it's possible it's going to be taking a whole lot of the resources out of that node, and then the other nodes will not be able to work, which is not good because eventually Kubernetes will end up killing that pod. Because that's one feature in Kubernetes. If a pod is using too much resources, way too much resources, it could decide to kill it. That will not be good for your application because you want your application to be always running. So as a best practice, you have to specify what we call the request. And I'll show you in a moment. The request is telling Kubernetes this is the minimum that my pod might need to be able to run. Then it knows, okay, this node has enough or not. If node 1 doesn't have enough, it puts it on node 2. If node 2 doesn't have enough, it can put it on node 3. So it knows how to schedule your pod so that it can get at least enough resources to run. The second thing is called the limit. Limit, as the name says, is the limit, the maximum that your pod can use. So if you specify the limit, it knows that once it gets to that level, it's not going to allocate any more resources. And overall, we have this for the RAM, the memory, and the CPU. Those are the two things you control with it, CPU and RAM. So you can see here it's complaining that the CPU request is not set and the CPU limit is not set. Also, it says the memory request is not set and then the memory limit is not set. So those are the 4 things it's complaining of there, apart from running it as root, as a non-root, and also, well, apart from running it as root, and also apart from not running it with a read-only root file system. These are the 4 things it's complaining of. So we need to fix all these issues, and then the pod, when we do run the check again, the pod will now give us a go-ahead, like give us a thumbs up to say everything looks good. Now this pod can run. Okay, in order not to waste time in fixing those issues, I believe I had one here, which I fixed. Okay, so yeah, this one here, it's fixed. All the issues it's complaining about, I put them here. Remember before this pod was very simple, but now I added, it was saying we should add to security context. So we have the security context there that says run as user with ID 1000. Run as group, the group should be under 3000. This file system group, this one is optional. I can as well delete that, but at least because I'm running it as a non-root user, as a real user, that error message will disappear. Then for the containers, I'm setting under the resources, I'm setting the request for the CPU and the RAM. Yes, it's memory and RAM, memory and CPU, and then for the um, for the request is there, and then let's say we have for the limit. Okay, I don't have that set here, so that should be probably another file. But so we have the request here, but I don't have the limit. Okay, so let's run it against this file and see. So again, we say KubeLinter, KubeLinter lint, lint, and then let's call it pod.xml. Okay, so this one still has some errors because you can see it didn't have 6 because most of those were set. For example, we set the request, but we didn't set the limit. So now it's complaining of those. And then we also ask it to run as non-root, so it's not complaining anymore, but we have not asked it to run as a as a read-only root file system. So out of the 6 checks here, 3 were fixed, and now we have 3 more left to fix. So again, I have another one here. Let me say cat nginx.yaml. Okay, so this one here, let me open this one here, nginx.yaml. So you can see for this one here, I have a security context, which I set it to be read-only root file system to true. That's what it was suggesting to us. So we should do that. Then we set the resources, we set the request for both of them, and then we set a limit for both of them. When I say both, I mean memory and CPU. So we set all those ones there, which means all the things it was complaining of, we set them. We already fixed them. We ask it not to run as root. We set the read-only file system to be true. Then we set the limit for RAM and CPU. And then we set the request as well. Remember, the request is the minimum required. The limit is the maximum that this system will use. So now if I save or quit this one, and I say KubeLinter lint nginx.yaml, now it said no lint errors found. So now it's like saying this pod can now run in production. All right, so what have we learned so far? We see that the fact that you have a YAML file which is running in Kubernetes doesn't mean that that file is secure. In production environment, this can be dangerous, really, really dangerous. And so KubeLinter will help you to check, okay? And as you can tell, even though they have a lot of these checks and policies in place, it's going to be left for individual teams in organizations to say, okay, these ones are important for us, so we're going to make sure we check against these checks, checks by default. Any pod that we want to go into production must have to pass these checks. And anyone that you think is not important for the organization, if you think it's not a big deal, maybe you can disable them. But certain things you must want to make sure that they passes before they go through. So that's just an example I showed you just from a very simple file. Even though we created it, auto-generated it, the system was fine, the pod is working fine, but in reality, that pod is not secured because it wasn't created with best principles, best practices for creating YAML files, and so it's prone to a lot of attack from outside. And the fact that you can tell your developers, can teach your developers to make sure that they follow this process, and the fact that they can install this in their laptop and use it makes it quite a handy tool. And not surprising, that's why, it's one of the most popular tools. It's simple to use. All you have to do is just run the lint against your YAML files, and then the system suggests to you, hey, you may want to do this, you may want to do that. Then you go ahead and fix them. And if you're not that familiar with Kubernetes, all the fix here could be difficult for you. But really, if you're familiar with Kubernetes, these are things you may have come across a couple of times. So they are not such a big deal, and the fact that it's telling you what to do to fix them is a good thing. Maybe the only thing it could do now is to actually help you fix them, okay? But maybe that's in the way, I don't know, but fixing them by yourself is a lot, at least you know what to do. It tells you what to do, so you can easily go ahead and fix them, which is good on its own. All right, so that is KubeLinter. You can, even though I'm checking them against a single file, you can check them out across a bunch of files. Okay, so for example, here, where I am here in this directory here, I have a lot of files here under manifest folder, and I can say KubeLinter lint, and I can lint against the entire folder. All right, so now there are a lot of files there, so it found 53 errors across all those files. This one here is said container user DB has CPU limit. Okay, so it's kind of like the same thing it was complaining for each one of them. Limit, request, non-root, limit, request, non-root. It's kind of the same thing, but because a lot of files, it's giving me all these errors. Then I can now go ahead and fix them like I did earlier. And then after that, I can now, put all this application into production. So you don't have to run them against single files. You can run them across an entire directory and then, or a folder, and all the files there will be checked all at once, and then the system will report to you, then you can go ahead and fix them. Okay, so let me show you this one too. If you do not want to run them across all, if you don't want all the checks, then you can go to manifest file here. This one here is actually a run through. Yeah, it's kind of like a walkthrough that you can take from their website. Okay, so under config, you have config. Let's see, do not auto load. So let's copy this one here. Let's say do. Okay, so if you look at this file here, this is where I'm now talking about configuration. How do you customize the checks, only the checks that you want, based on what I was saying earlier? Maybe the team in this case think that they don't want all these checks. So all of them are commented out. All these ones you see are commented out. The only thing that is important here is privilege container, check, and run as non-root check. Those are the only thing. But you can see there are a lot of checks here, but these are the only ones who want to check against this particular pod. So now you have it there, and then now you can run the check against that, okay, just against that. So I have all that here to make it easier. Excuse me. So now let's run against this one. I'm just going to say Control A. So now we're running KubeLinter lint against this manifest, but we're going to use this configuration file, and we're going to pick it from this directory, the file I just opened for you. And in that file, we only have 2 checks open. So now run it against, and it found only 9 errors because we only check against 2 things. Now before, how many did they find? A lot of them, because we ran against a whole lot of checks. So it was able to find like 53. But you might say that again, your team, you don't care about all those. The only 2 you care about. Then 9 only found 9. So I think it's a very handy tool. You can customize it to do the checks you want. If you wanted to do all the default, you can do them. If you want to customize based on what you want, you can also go ahead and do just those checks. But at the end of the day, it's left for you to be able to fix them. It's left for you to go ahead and try to fix them. And then after that, you can get things the way you want them to be. And I believe that's all I have to show you for tonight. So first of all, like I said, this was going to be a kind of a beginner-friendly meetup, because sometimes we have a meetup, somebody comes and do a presentation, and newbies may not understand what the person is talking about just because they don't have the fundamentals of Kubernetes to help them understand. So in this short presentation, I kind of walk you through, even if it's just to give an idea of what Kubernetes is all about and what it does. And then after that, I was able to show you what KubeLinter can do. Since we work with Yammer Files a lot, so it's a tool that makes it easy for you to check your Yammer Files to see if they are ready for production or not. If you are running in just for development, of course, you can say this is not a big deal. It's such a big deal. But before you put your Yammer Files into production environment, I would highly recommend you use a tool like this to check make sure that things are working as expected before you actually put them into production. All right, so let's see if there are any questions here so far. I don't know if anyone has any question. Let me see if any question has come through so far. So I'll leave you this time to ask questions. If there's no question, then I'll make a few, one or two announcements, and then we can, break. So while I'm trying to say one or two things, feel free to send your questions if you have any question to ask. Like I said earlier, this will be the last meetup for the year. So thanks, guys, for staying with us throughout the year. I hope that for those meetups that you attended, that they were useful. They are useful for you. We always need presenters. If you think you have something to share with us, with your colleagues, feel free to let me know, and then we can schedule you to give a presentation. So don't forget, we always need people to talk. I tend to talk when there's no one to talk for that meetup. But if there's someone else to talk, I'm happy to give them the opportunity to talk. Okay, so take note of that for next year. Next year, as things improve, we'll try to resume, in person. So even if we're doing online meetups, at least we can have both of them. We can have people available for face-to-face interaction. Then we can have people connecting through, like you're doing at the moment. So we have both options open for people to to get involved with that. And like I said at the beginning as well, this is all sponsored by cloud technology experts. And for the kind of things we do, if any of those interest you, then feel free to check the website, feel free to contact if that is what you are looking for. And so other than that, I hope you have RSVP for the movie coming up. I have already RSVP, and if you're able to make it, hopefully I'll see you there. I think it's a great opportunity to be able to meet some of you in person, since we haven't seen for maybe getting to 2 years. We need to meet we should meet every Sunday, every Wednesday, but now we haven't met for so long. So if you can RSVP, that would be good. But other than that, I want to wish you Merry Christmas, Happy Holidays, have a good time, and then we'll resume again in January. So again, thanks for your support and have a good evening.